irrational and real numbers. In this module, you will learn about irrational numbers and real numbers. First, consider irrational numbers. Irrational numbers are the real numbers that cannot be expressed as the ratio of two integers. Consider the numbers √2, √3, and √5. These numbers cannot be expressed in the form p by q. Thus, these are irrational numbers. Next, consider proving a number to be irrational. Suppose you have to prove √2 to be an irrational number. This will be proved by contradiction. Suppose √2 is a rational number. So, √2 can be expressed in the form p by q, where p by q is a rational number in its reduced form. That is, p and q have no common factor other than 1. Next, square both sides of the equation. Thus you get 2 is equal to p square by q square. From here you get 2q square is equal to p square. As the expression on the left-hand side is a multiple of 2, you can say that p square is even, which further means p is even. Thus you can write p as a multiple of 2. Let p is equal to 2k, where k is an integer. Next, on squaring both sides of the equation, you get p square is equal to 4k square. Now, on substituting the value of p square in equation 1, you get 2q square is equal to 4k square, which gives q square is equal to 2k square. As the expression on the right-hand side is a multiple of 2, you can say that q square is even, which further means q is even. Thus, both p and q are even, which means 2 is a factor of both, or they have a common factor other than 1. Thus, the assumption that √2 is a rational number is wrong. Therefore, √2 is an irrational number. Similarly, you can prove √3, √5, and √7 to be irrational numbers. Now, consider real numbers. The numbers that can be represented by points on a number line are called real numbers. In other words, every point on a number line is associated with a unique real number, and every real number is associated with a unique point on a number line. Thus, every rational and irrational number is a real number. In this module, you have learned irrational numbers are real numbers that cannot be expressed as the ratio of two integers. How to prove a number to be irrational